I call this a Raspberry Pi-based humidity clock. It connects to weatherunderground.com every 4 minutes and fetches the current weather conditions for the location I choose, and it displays the relative humidity on an analog dial. Why humidity? Well, where I live, relative humidity can spell the difference between a pleasant day and a miserable day outdoors, and besides, it's a fixed scale between 0 and 100, so it's easy to design a gauge for it. I'll talk more about some simple mods to make it do other things after I show you the build. This project started off with a broken mantle clock from Target. The battery in the movement leaked, rendering the clock inoperable. So I removed the clock movement and replaced it with a 5-volt unipolar stepper motor. Then I designed a new clock face for it. The original one was just a sheet of paper taped to the cardboard face backing. I made my own custom gauge in Inkscape, adding some fun details like a Raspberry Pi logo and the Weather Underground logo. It's taped down just like the original clock face was. Next, I needed a custom circuit board for the inputs and outputs. The motor takes 5-volt inputs, but the Raspberry Pi's GPIO pins output at 3.3 volts. So the circuit board needs a multi-channel amplifier, like this Darlington driver here, that amplifies the 4 outputs to the required 5 volts. Also on the board are these 2 pairs of terminals for 2 inputs. They have pull-down resistors so the input voltage is never floating, and they're here so a pair of momentary switches can be read by the Raspberry Pi. The custom circuit board has its own home here in the clock body and connects to the stepper motor with this header. Finally, there's a Model A Raspberry Pi in here with an Element 14 Y-Pi adapter. The Raspberry Pi is the heart of the clock, running a custom Python program that connects to weatherunderground.com and interacts with the custom circuit board to control the stepper motor. The Python program is on our webpage and is pretty nicely commented, so it should be easy to follow or adapt. With everything together, here's what happens when you turn it on. The Raspberry Pi goes through its boot sequence, connects to the network, and then loads the Python program. The program connects to weatherunderground.com, fetches the current conditions for the location identified in the script, and then instructs the motor to move that many steps. But wait, there's a problem. How can the Raspberry Pi know where the pointer was pointing when it started? It can't know. That's what the input buttons are here for. I use them to 0 the clock, and then it turns the hand again to the last red value for relative humidity. Now the clock is calibrated and will continue to accurately display the conditions until the next reboot. So does it only do humidity? Will it only show me local data? No! Little changes to the script could have it showing you the temperature in Taipei or the accumulated precipitation in Port-au-Prince. Take a look at the code and see how you would change the function of this clock to suit your needs.